Hello students, welcome back to Code to Serve Academy. Today we will study about irrational numbers. Okay, so in previous class we have studied about decimal expansion and the types of decimal expansion, in which we have studied about our decimal expansion is of two types. The first one is terminating decimal expansion and the second one is non-terminating decimal expansion. In terminating decimal expansion, we have seen that how can we express terminating decimal expansion into a rational number. Also, for non-terminating decimal expansion, we have seen that it is also of two types. The first type is non-terminating and recurring decimal expansion, and the other type is non-terminating and non-recurring decimal expansion. In this, we have seen how to convert non-terminating and recurring decimal expansion into a rational number. Okay, so we were left with the case of non-terminating and non-recurring decimal expansion. These type of decimal expansion are basically not a rational number. Okay, so what are these numbers which are not a rational number? We will study in this class. Okay, so first of all, till now we have studied about how to express a decimal expansion into a rational number. Till now we have studied how to express a decimal expansion into a rational number. But if the opposite case is given to us, that a rational number is given, we have to find out that the number is terminating or non-terminating. But one condition is given, that we do not have to find the decimal expansion. Okay, that means we do not have to use the long division method. So without using long division method or without knowing the decimal expansion, how can we find the rational number as terminating or non-terminating recurring decimal expansion? Okay, so we are not finding the decimal expansion. We are making a fact. By using that fact, we can understand that a given rational number is terminating decimal has terminating decimal expansion or non-terminating recurring decimal expansion. Okay, so we are going to find out a fact through which we can deal with this. Okay, so the trick is, first of all, whatever the rational number is, let us suppose the rational number is 22 upon 50. Okay, so what we have to do first, we have to first make this rational number in its lowest term. So we know that 22 and 50 both are divisible by 2. So we can make this number as 11 upon 25. Now this p and q belongs to the set of integer. Q is not equal to 0 and p and q have only one factor, common factor, that is 1. So it follows the basic prime conditions of the rational number. Basic conditions of the rational numbers are followed. So that is why this is the lowest term of a rational number. So whatever the rational number is given to us, first of all, we will convert that rational number into its lowest term, and then we will factorize the denominator. We will prime factorize the denominator. Let us suppose that 25. So for 25, we know that it is 5 to the power 2. We know that it is 5 to the power 2. The prime factorization of 25 is 5 to the power 2. So the second step is, if the denominator is in the form of 2 to the power m, 2 to the power m into 5 to the power m, then we can say that the rational number is terminating. For example, in this case, what we are getting 11 upon 25 as 11 into 5 to the power 2. Also, for m and n, the condition is m and n should belong to the set of whole numbers. That means m and n can also be 0. Okay. So here we can write this rational number as 11 upon 2 to the power 0 multiplied with 5 to the power 2. So this rational number has been expressed as in the form of 2 to the power m into 5 to the power n in the denominator. Okay, so that is why we can say that this rational number is terminating. We haven't find out the decimal expansion, but we have said that it is terminating or not through this concept. Okay, and the other one, let us suppose that we are given a number. Let us suppose that we are given a number 1 upon 15. We are given a number 1 upon 15. We know that this is the lowest term of a rational number. Okay, so in the denominator part, on prime factorization of 15, what we will get? We will get 3 into 5. That means 3 to the power 1 into 5 to the power 1. Let us suppose that here is 2 to the power 0, because to anything to the power 0 is 1. So we are getting 2 to the power m into 5 to the power n in the denominator. But also one more factor. But also one more prime factorization of prime factor is there, that is 3. So if we are getting any other prime factors other than 5 and 2, then we say that rational number as non-terminating and recurring rational number. So this decimal expansion of this rational number will be non-terminating and recurring. So let us check what we have said. This rational number will be non-terminating and recurring. Also, we have said that this rational number will be terminating. Will be terminating. Let us check it is true or not. If it is true, then for any case we can take this as a fact. Okay. So what we are going, we are checking that it is true or not. First of all, let us suppose that we are given 11 upon 25. Okay. So what will be the value of 11 upon 25? What will be the value of 11 upon 25? So 11 upon 25 can also be written as 11 into 4 by 25 into 4. So why I have written 25 into 4 in the denominator? I have written 25 into 4 in the denominator because 25 into 4 is 100. So what we are getting? We are getting 44 upon 100. So it will be 0.44. So what we have seen, this rational number is actually is having a terminating decimal expansion because it is ending after decimal points. Okay. Similarly, the second rational number is 1 upon 15. 1 upon 15. So what will be the value of 1 upon 15? Let us suppose we are dividing 1 with 15. What we will get? First of all, we have to include 2 0. That means it will be 0.0, and 15 into 6 will be 90. So we will get again 10. Again it will be 6. We will get 90. Again 10. We will get 90. So this 6 will be continued on. So what we are getting, this rational number as 0.066666 continued up to so on. So this rational number is repeating itself after 6. Okay, so we can say that this rational number has non-terminating and recurring decimal expansion. Okay, so that is why through this fact also we can say about any rational number that which rational number is terminating and which rational number is non-terminating and recurring. Okay, we have to do only this part. This part was to check whatever we have done is true or not. Okay, now moving to our next part. What is our next part? Our next part is the definition of irrational numbers. The definition of irrational numbers. So what do we mean by irrational numbers? What are irrational numbers? So any number which is not a rational number is termed as a irrational number. From class 7, class 8, we have studied that a number which is not a rational number is termed as irrational number. For example, let us suppose we are going to find out the value of root 2. Okay. So square root, we know that this set Q, this set of rationals contains set of natural number, set of whole number, set of integers in it. So other than this is a set of square roots of numbers, in which what I am saying, square root of 2 is not known. So it is not a rational number, because we know that any rational number can only be in the form of these. Okay. So this, the value of root 2 will be, it is not known to us. Okay. So right now the value of root 2, root 3, these type of numbers are not rational numbers. So we can say these numbers as irrational numbers. Okay. Now moving to our more precise definition. What we are getting for square roots, root over 1 is actually 1, and 1 belongs to the set of natural number. So it is a rational number. So what type of numbers will be irrational number? So if we go through these numbers, root 2, root 3, root 5, root 6, root 7, we are getting that these are root of imperfect squares. What it is? It is root of imperfect squares. So root of imperfect squares are always irrational numbers, because they are not rationals. Okay. Similarly, the more precise definition is, if we are not getting the value of a number exactly, if the exact value of a number is not known to us, then we say that number as irrational number. For example, let us suppose we are finding the value of root 2. Okay. What we are getting, the value of root 2 is 1.414213562373095048 and continued up to so on. So this number, this decimal, these digits after a decimal are going on continuously. We are unable to find out what will be the last digit. Okay. So the exact value of these numbers are not known to us. So these numbers are said to be irrational number. One more precise definition is that in non-terminating, in non-terminating and non-recurring decimal expansion, we have seen that these type of numbers are not rational number. Okay. So these, the numbers which are not rational number are said to be irrational number. So these numbers can also be irrational numbers. Okay. So what I am saying, let us look into the value of root 2. The value of root 2 is 1.414213562373095048 and continued up to so on. What we are getting, this is a non-terminating decimal expansion. What we are getting, this is a non-terminating decimal expansion. Also, after decimal, we are not getting any repetition of digits. We are not getting any repetition of digits. That is why we can say that this decimal expansion of this number is neither terminating and nor recurring. So we can say that this number is an irrational number. Okay. So through this, we have concluded that the basic definition for rational numbers should be, it should not be a rational number, or else we can say that its value should not be exact. Its exact value, we cannot find the exact value of that number, or else we can say that any decimal expansion which is neither terminating nor recurring, we say that decimal expansion as irrational number. Okay, so the examples for irrational number will be root 2, root 3, root 5, root 7, and let us suppose that we are given cube root of 3, cube root of 6, fifth root of 7. So these numbers will be irrational number. These numbers value is not known exact to us. Okay, so we can say that these numbers are irrational numbers. So whenever you will be asked define irrational numbers, we will use this third definition. We will use this third definition. What is this third definition? The numbers whose decimal expansion are neither terminating nor recurring are termed as irrational numbers. Okay, the examples are like this. Some more point to note in it. You all have studied about surds. You all have studied about surds in class 8. Okay, so what are surds? Surds are written as nth root of a. Okay, so whenever this nth root of a is not a rational number, let us suppose that we have given a number like nth root of 2. So we don't know the nth root of 2 value, the exact value of nth root of 2. So it is not a rational number. Whenever this number is not a rational number and n is a positive integer, a is a positive rational number, a is a positive rational number. What is a here? This 2 is a. Okay, and this n is positive. So what we are getting, whenever this n is a positive integer, this a is a positive rational number and nth root of a is not a rational number, then we say this surd as an irrational number, because this is not a rational number. We know that any number which is not a rational number is termed as an irrational number. Okay, so this nth root of a will be an irrational number if and only if this nth root of a is not a rational number. So what I am saying, this nth root of a can be a rational number and cannot be a rational number sometimes, and cannot be a rational number sometimes. When it will be a rational number, let us suppose we are finding cube root of 1. So what will be cube root of 1? This will be 1. So this is a rational number. So this nth root of a is sometimes a rational number. Let us suppose we are given, we are going to find out the cube root of 8. So cube root of 8 will be what? It will be 2. It will be 2 because 2 to the power 3 is 8. So through this, cube root of 8 is a rational number. Okay, so you are getting the facts. Sometimes what we are getting, sometimes we are getting cube root of a is a rational number, nth root of a is a rational number. Sometimes we are getting nth root of a is not a rational number. Let us suppose that we are given cube root of 5. So we cannot find the exact value of cube root of 5. So that is why I am saying the nth root of a which are not a rational number are said to be irrational number. So all the surds which follow these conditions are not a rational number, are irrational number. Okay. So for the definition of surds, what we have seen, the numbers, that numbers which are in the form of this, is not a rational number, a is a positive rational number, n is a positive integer. If these three conditions are followed, then we say this as a surd. Okay, whenever, what I was trying to say, you first understand, for surds, let us suppose that we are writing cube root of 8, we are getting 2. Okay, so this is not a surd because we are getting a rational number. So those nth root of a which are not a rational number are said to be surd. Okay, So this is a surd. Only if it should be not a rational number. Okay, if it is a rational number, then it is not a surd. We will only say that it is cube root of a, which is a rational number. For surd definition, it has to not be a rational number. Okay, so this is the basic concept behind this, that surds are those nth root of a which are not a rational number. So what are surds? Surds are these type of numbers which are not a rational number, where n is a positive integer and a is a positive rational number. Okay, I don't think that you have any doubt about surds now. So if you are asked, give some examples about which numbers will be rational numbers, then you can say all surds will be an irrational number. Okay. Now moving to our next part. What is our next part? We are going to represent irrational numbers on real number line. You all know that our highest known number line is real number line. Our highest known number line is real number line. Which type of sets it's comprised of? We know that the set of real numbers, comprises the set of rationals and the set of irrationals. Okay, so together these two sets make set of real numbers. So we already know how to represent set of rationals in number line, but we are not known how to represent set of irrationals on number line. So today we are going to learn how we will represent set of irrationals or the numbers which are irrationals in real number line. Okay, so let us move to our first question. Our first question is represent root 2 on real number line. What we are going to do? We are making root 2 represented in the real number line. So we know that our real number line is like this. In our real number line, we have 0, 1, 2, 3, 4, 5, 6 continued up to so on. And in between these units, we have all rationals and irrationals. Okay. Similarly, in the left part, we are having -1, -2, -3 and continuously up to so on. So, we are finding out the value of root 2. So, where it be? So, we will use Pythagoras theorem here. We all know that for Pythagoras theorem, h square is equal to b square plus p square. What it is? H square is equal to b square plus p square. If this is a right angle triangle, let us suppose that this is a right angle triangle. Okay. So for this right angle triangle, this will be the base, this will be the perpendicular, and this will be the hypotenuse. Okay. So for this triangle, by Pythagoras theorem, we assume that h square is equal to p square plus b square. We assume that h square is equal to p square plus b square. What it means? That h is root over p square plus b square. Okay. So if we are going to represent root 2, how can we find out that root 2 is can be expressed in the form of Pythagoras theorem? We know that square root of 1 plus 1 is root 2. So it can be written as root 2 is equal to root over 1 square plus 1 square. So it has been expressed in the form of root over b square plus p square. It has been expressed in the form of root over b square plus p square. So here the value of b is 1, the value of p is 1. So what we are going to take? We are going to take b as 1 unit and p as 1 unit. Okay. So after taking b as 1 unit and p as 1 unit, we will get this hypotenuse as root 2 unit. So now this is root 2 unit, but we have to represent it in our number line, and our number line is here. So in this we have to represent where is root 3. So what we will do? We will mark out a compass here, and after getting done, we will find out that this will be our value of root 2, which is equal to root 2 is equal to something like 1.414 approx. Okay. So through this way, we can represent root 2 in our real number line. Similarly, if we are wanting that we are going to represent root 3 on real number line, we are going to represent root 3 on real number line. It is an irrational number. We all know that root 3 is an irrational number. So for this root 3, how can we represent this root 3 in real number line? How can we represent this? So right now, we have studied how to find root 2 unit. We have studied that for root 2 unit, we have to take B as 1 unit and P as 1 unit. The base should be 1 unit and perpendicular should be 1 unit. Then we can get root 2. Also, if we think of this, root over root 2 square plus 1 square is actually root 3. What we are getting? Root over root 2 whole square plus 1 square is actually root over 2 plus 1, that is root 3. So for root 3, what we are getting as B and P? We are getting as B as root 2 and P as 1. So if we are taking our base as root 2, if we are taking our base as root 2 and our perpendicular as 1 unit, what we will get? We will get root 3 unit. We will get this as distance as root 3 unit. So we have to represent this root 3 in our real number line. So how we can do this? We will place the compass here, and after going to our original place, what we will get? This root 3 will be here. So we have represented our root 3 and it will be approx root 3 is equal to 1.732. Okay, it will be approx root 3 is equal to 1.732 approx. Okay. Similarly, if we are asked to represent root 10 on real number line, if we are asked to represent root 10 on real number line, how can we represent? So for root 10, it is very simple. We can represent root 10 as, we can rewrite root 10 as root over 3 square plus 1 square. What it means that our base will be 3 units and our perpendicular will be 1 unit. We can take any of it. We can take P as 3 units, we can take B as 1 unit. Okay, we can also do this. But for here, if we take B as 3 units and P as 1 unit, what we will get? Let us suppose I have taken B as 3 unit and P as 1 unit. So this value, this distance will be root 10 units. It will be root 10 units. So after getting it done with our compass, we will find out that root 10 is like here. So we have represented root 10 in our real number line. Similarly, if we are asked root 17, root 13, anything, we can do this. Okay. So by this, you have understood till now that what is an irrational number, how can we represent irrational number on real number line. Now we will move towards the contradiction part, proving any irrational number through contradiction. So contradiction method is a very useful method to prove irrational numbers. First of all, we can prove any irrational number through 3 methods. First method is exemplar method. For example, I have making you understand that any number which is not a rational number is an irrational number through examples. Okay. Similarly, I have make you understand that any number whose exact value is not known are termed as irrational number through examples. The first method through which we can find out which numbers are irrational are exemplar method. The second method is contradiction method. The second method is contradiction method. So we will learn today about contradiction method, and the third method is principle of mathematical induction, which you will study in higher classes. Okay. So I am going to make you learn about the contradiction method. How can we prove root 2 is an irrational number through contradiction method? Okay. So what I am going to prove that root 2 is an irrational number. What I am proving? Root 2 is an irrational number. How I can do this? how I can prove that root 2 is an irrational number? You all have learnt about chor sipahi thing. For example, if you are watching CID like things, you always get to know that the police person, what they do, they treat the criminals as not they are criminals, and they wait for a chance that the criminal make a mistake and we find out the criminal. For example, we have n number of people, okay, and what we are saying, the police are thinking that we will suppose that all are not criminal, but one person will be there in between them who will do some mistake, and we will find out that he is not following the condition of good people, or he is not following the condition of good person, so we can say that he is the criminal, okay, he or she is the criminal. For example, if we are finding that root 2 is an irrational number, first of all, let us think that root 2 is not an irrational number. Let us suppose that root 2 is not an irrational number. We are thinking opposite of that, okay. So what we are thinking, that root 2 is a rational number. So to prove this, we will require two important theorems. The first one is, if a and n belongs to the set of natural numbers and p is a prime number which divides a to the power n, then p will divide a. Right now, you understand this part only. Let us suppose that 2 is a prime number and it divides p to the power 2. 2 is a prime number, 2 is a prime number, okay, and it is p to the power 2. What is p? This a. This is a natural number, this is a natural number, and 2 divides p square. So from this theorem, what we can say, this 2 divides p square or p to the power n, then we can say that this 2 will divide p. What we can say? This 2 will divide p. Similarly, what I am trying to say, that if p is a prime number and a and n belongs to the set of natural number and p divides a to the power n, then we will say p will divide a. This is an important theorem. Without using this theorem, we cannot prove this situation, okay. We cannot prove root 2 as an irrational number. Also, if p divides p is any number, if p is dividing ab, product of ab, let us suppose that 2 is dividing 6. Let us suppose that 2 is dividing 6. That means 2 is dividing 2 into 3. To divide 2 into 3, what it means? Either 2 will divide 2, or 2 will divide 3, or 2 will divide 6. 2 or 3 both. What I am saying, either 2 will divide 2, or either 2 will divide 3, or either 2 will divide 2 and 3 both. मतलब क्या है कि अगर मैं बोल रहा हूं कि 2 जो है ए बी को डिवाइड कर रहा है, 2 6 को डिवाइड कर रहा है, और 6 को हम लोग 2 इंटू 3 के फॉर्म में लिख सकते हैं, ए बी के फॉर्म में लिख सकते हैं, तो 2 या तो 2 को डिवाइड करेगा या तो 3 को डिवाइड करेगा। ऐसा कर नहीं रहा है, 2 3 को डिवाइड कर नहीं सकता है। हम बस एक कंडीशन ले रहे हैं कि या तो 2 2 को डिवाइड कर सकता है, या तो 2 3 को डिवाइड करेगा, या तो फिर 2 और 3 दोनों को डिवाइड करेगा। फॉर एग्जाम्पल, अगर हम बोल रहे हैं 2 डिवाइड्स 4, तो हम क्या बोलेंगे? 2 2 को डिवाइड कर रहा है, और ये 2 फिर से 2 को डिवाइड कर रहा है, और 2 2 एंड 2 को डिवाइड करेगा, क्योंकि इस 4 को हम 2 इंटू 2 के फॉर्म में लिख सकते हैं। तो इस केस में क्या हो रहा है? तीनों कंडीशन फॉलो हो रहा है। तो हम क्या बोल रहे हैं कि जब भी P ए बी को डिवाइड करेगा, प्रोडक्ट ऑफ ए बी को डिवाइड करेगा, तो P या तो ए को डिवाइड करेगा, या तो बी को डिवाइड कर सकता है, या तो फिर ए और बी दोनों को डिवाइड कर सकता है। समझ में आ रहा है? ये दो थ्योरम को हम लोग यूज करेंगे। क्लियर है? अब हम लोग चलते हैं, इसके बारे में समझते हैं कि ये थ्योरम को हम लोग कैसे प्रूव करेंगे। लेट अस सपोज कि हम मान लेते हैं कि रूट 2 एक रैशनल नंबर है। क्या मान लिए? कि रूट 2 एक रैशनल नंबर है। अगर रूट 2 रैशनल नंबर है तो इसको हम लोग पी बाई क्यू के फॉर्म में लिख सकते हैं। किस फॉर्म में लिख सकते हैं? पी बाई क्यू के फॉर्म में लिख सकते हैं। अगर रूट 2 पी बाई क्यू के फॉर्म में है, और कंडीशन क्या होगा रैशनल नंबर्स का? द कंडीशंस विल बी पी एंड क्यू विल बिलोंग्स टू द सेट ऑफ इंटीजर, q will not be 0 and p and q have no common factors except 1. p और q के पास कोई और दूसरा फैक्टर नहीं होना चाहिए 1 को छोड़ करके. ठीक है. Now when we are squaring both the sides, what we will get? Root 2 का whole square, that means 2 is equal to p square upon q square. We are getting 2 as equal to p square upon q square. What it means, on cross multiplying the terms, p square will be equal to 2q square. So let us suppose this is our first equation. P square is equal to 2q square. We are making this equation as an important equation for our use. Okay. So we are getting p square as equal to 2q square. Now we know that 2 will divide 2q square, since 2 is a factor of 2q square. So we can say that 2 will divide 2q square. Since what I am saying, that let us suppose if 2 is dividing 4, what it means, 2 will divide 2 or 2 will divide 2 or 2 will divide 2 and 2. Okay. So what I am trying to say, if 2 divides 2q square, what it means, how can it define divide 2q square? Since 2 is as a factor, so it will divide 2q square. Let us suppose what I am trying to say, 2 is trying to divide 2q square. So when we multiply this 2 with 2q square, what we will get? 2q square. So 2 can divide 2q square. Okay. So we are getting 2 will divide 2q square. If 2 is dividing 2q square, what it means? 2 will divide p square from equation 1. p square is equal to 2q square. So मैं क्या कह रहा हूं, p square is equal to 2q square है और हम लोग जानते हैं 2 2q square को डिवाइड करेगा. क्यों करेगा? क्योंकि 2 को अगर हम लोग 2q मतलब 2q square को अगर हम लोग 2 से डिवाइड करें तो हम लोग देख क्या रहे हैं, 2q square पूरा का पूरा डिवाइड हो जा रहा है q square के टर्म्स में, है ना. तो हम लोग क्या बोल सकते हैं कि 2 जो है 2q square को डिवाइड करेगा. अगर 2 2q square को डिवाइड कर रहा है और 2q square p square के बराबर है तो हम लोग क्या बोल सकते हैं कि 2 p square को भी डिवाइड करेगा. समझ में आ रहा है? 2 p square को भी डिवाइड करेगा. और एक चीज, what I am trying to say, from our theorem we have seen that if p is dividing, p is a prime number and p is dividing a to the power n, it will divide, p will divide a also. Similarly, अगर यहाँ पे हमने पहले देखा कि अगर कोई एक प्राइम नंबर a टू द पावर n को डिवाइड कर रहा है तो वो a को भी डिवाइड करेगा. तो यहाँ पे हमने क्या देखा कि 2p स्क्वायर को डिवाइड कर रहा है. तो पहले थ्योरम को अगर हम लोग यूज करें तो हम लोग बोल सकते हैं 2p को भी डिवाइड करेगा. ठीक है, 2p को भी डिवाइड करेगा. अगर 2p को भी डिवाइड करेगा तो हम लोग p इज इक्वल टू 2k लिख सकते हैं. मान लेते हैं 2p को डिवाइड कर रहा है, मान लेते हैं k टाइम्स में डिवाइड कर रहा है, तो हम लोग क्या लिख सकते हैं, p इज इक्वल टू 2 इंटू k प्लस 0. सो p इज इक्वल टू 2k के रूप में हम इसको लिख सकते हैं, जिसमें k क्या होगा, एक नेचुरल नंबर का मेंबर होगा. k क्या होगा, एक नेचुरल नंबर का मेंबर होगा. तो हमने p को 2k के फॉर्म में लिख सकते हैं इस कंडीशन के थ्रू. ओके, हम क्या कर रहे हैं, p इज इक्वल टू 2k को इक्वेशन नंबर 2 ले ले रहे हैं. व्हाट वी आर डूइंग, we are taking p is equal to 2k as equation number 2. Using this p is equal to 2k in equation number 1, what we will get? Using this p is equal to 2k in equation number 1, what we will get? 2k to the power 2, 2k to the power 2 will be equal to 2q square. What we will get? We will get 2k to the power 2 means 2k into 2k. That means it is 4k square, and 4k square will be equal to 2q square. So we will get q square as 2k square. 2, this 2 will divide 4 as 2k square. So this q square will be equal to 2k square. So we are writing this equation as equation number 3. So what we are getting, q square is equal to 2k square. Now the similar thing will happen. We know that 2 will divide 2k square, sorry 2k square. So when 2 is dividing 2k square and 2k square is equal to q square, what it means? It means 2 will divide q square also, because q square is equal to 2k square. Okay, this q square is equal to 2k square, and we know that 2 is dividing 2k square. Since 2 is dividing 2k square, we can say that 2 will divide q square from 3. So, if 2 is dividing q square, 2 is dividing q square, and from theorem 1, we have seen that if E2 is a prime number and it is dividing a to the power n, so it will divide a also. So, 2 will divide q also. Okay. So, what we are getting? We are getting first that 2 will divide p, and right now we are also getting that 2 will divide q. Also, we also have seen that when we have taken root 2 as irrational or as rational number, what we have seen that p and q have no common factor except 1. P and q have no common factor except 1. P and q have no common factor except 1. So what I am saying, we have got one more factor, that is 2. Since we got 2 divides p and 2 divides q, that means 2 is one more factor other than 1 in this. So we are getting a contradiction. If root 2 was a rational number, it has to follow that it has only one common factor. But what I am saying, that it has the other common factor as 2. Okay. So that is why we can say that it is not following the condition for a rational number. Since it is not following the condition for a rational number, what we can say? We can say that our supposition that p and q have only one common divisor was wrong. We will say that we got a contradiction. So root 2 is not a rational number. Whatever we were supposing that root 2 is a rational number is wrong. It is not a rational number. So whenever a number is not a rational number, what would it be? It would be an irrational number. So from this we can prove that root 2 is an irrational method. Through this method, we will prove some more examples, that is root 3 is an irrational number, root 5 is an irrational number, root 6 is an irrational number. Okay, you try this at your home and let me know where you are getting problem. Okay, thank you.